Now sketch the graph of the following, and two ways I'm going to show you how to graph those. One, if the base is bigger than 1, we know it's exponential growth. Such a graph will be sufficient. You just label the point 0, 1, draw it growing, and make sure to label the asymptote y equals 0. The reason this is an asymptote, no matter how small you chose x to be, that number will be close to 0 but never equal 0. That is, if I was to choose x to be negative 10, then 1/2 to the 10 power, that's 1 over 2 to the 10 power. That's a very small number, but it's not 0 and it can never be 0. That's sufficient. And if you would like to pick 3 points, in this case I never mentioned that, but the 3 main points that characterize this graph would be in that order if it's increasing, in that order if it's decreasing. So growth or decay. You could pick 3 points, and guess what those points are? Where does the power equal 0? A point above it and a point below it will do the trick. Throw a 0 in there. 7 to the 0 is 1. 7 to the 1 is 7, and 7 to the negative 1 is 1 over 7, so 0, 1. When x is 1, y is 7, so it's a lot steeper than this. 1, 2, 3, 4, 5, 6, 7. So the graph really looks like this, but the green is fine. And negative 1, 1 over 7, it's below. Like I said, all of these to me are the same. You don't lose anything on giving a rough sketch. If it says sketch a graph without saying labeling, you don't have to label anything. So here, the same deal. Since I've never came across a graph like that, I might want to say, you know what? Let's figure out where this equals 0. That equals 0 when x equals negative 1. A point above that is 0, and a point below that is negative 2. Put a negative 1 in there. That's 3 to the 0, which is 1. Put a 0 in there. 3 to the 1 is 3. Put a negative 2 right there. Negative 2 plus 1 is negative 1. That's 1/3. Negative 1, 1. 0, 3. And negative 2, 1/3. So you'll notice there's a small shift. This point should have been 0, 1, but now it is at negative 1, 1, and you could always find it by setting the power equal to 0 on every single one of those. Another way of looking at this is following this part. Since it is within the power, it's going to do the opposite. It's going to shift the graph of this 1 unit to the left, and you notice 0 moved to the left 1 unit. Here, do you see the number loose by itself? You could say, well, look, if you see a number loose, that's going to shift the graph 2 units up. It's going to take 4 to the x. I know what that looks like. 4 to the x is a graph that looks like this, because that's bigger than 1. This is going to shift the graph 2 units up. So you take y equals 0, shift it 2 units up, it becomes y equal 2. You need to show me that clearly. The point 0, 1, if you shift that 2 units up, that becomes 0, 3, and the shape is the same. Or you could say, forget all of that mess. I want to know, where does the power equal 0? At 0, a point above and a point below. That's more accurate. You don't need to if it's a sketch. Put a 0 in there. 4 to the 0 is 1 plus 2, that's 3. And what do you notice? That main point again. If I put a 1, I'll get 4 plus 2 is a 6. So when you go to 1, 1, 2, 3, 4, 5, 6. And a negative 1, if I put a negative 1, I'll get 1/4 plus 2. That's 2 and 1/4. 1, 2, and 1/4. There it is. A graph of y equal 1/2 to the x is exponential decay. It's a graph that looks like this. This is going to shift the graph 3 units to the right, and this is going to shift the graph 2 units down. So the point 1, 0, is going to shift 3 units to the right and 2 units down. The line y equals 0, shift it to the left or right, it stays horizontal, but you're going to shift it 1, 2 units down, and the shape is decaying still. That's more than enough. If you're not certain, guess what? 3 points will do the trick. The only catch, you have to figure out where the asymptote is. If you put a 3 right there, because that's where this equals 0, a point above 3 is 4, a point below it is a 2. Put a 3 right there, that's half to the 0, which is 1 minus 2 is a negative 1, and here's that point, 1, 2, 3, negative 1. If you put a 4 in there, you get 1. 1 half minus 1 is negative 1.5. 1, 2, 3, 4, minus 1.5. And if you put a 2 there, you get negative 1. 1 half to the negative 1. Isn't that a 2? Isn't that a 0? There it is. So graphically, you could either pick points, or you really don't have to. From now on, you could just use transformation. Now, time to use our calculator a bit. Something that brings exponentials out is really important. Would be those formulas. And here they say, a certain type of bacteria grows according to the function where P is the number of bacteria and T is the number of hours. Right there. Find the number of bacteria. What does P equal? After the given period of time had passed, round to the nearest whole number. If you're doing people or bacteria or, living organism, you go to the nearest one. They say when T equals 6, right there. Doesn't that mean the number of bacteria will be 1000 e to the 0.1912 times, and the only thing that's going to change, you're going to put a 6 there, and this is where you're going to make use of your scientific calculator. Yes, you get your rush, you get to use your calculator now. 1000 e is right underneath natural log to the 0.1912 multiplied by 6, 3149.36, so roughly 3149 bacteria would be present. If I was to say, do you know how many bacteria they started with? It's just curious. Do you know how many bacteria they started with? Isn't that at time equals 0? If you put a 0 right there, doesn't that make that a 0? Isn't e to the 0 1? Do you see where the initial amount is? That's always the initial start. Just saying. Helps to know these things. And what if we wanted to put some money in a bank? Here's a formula. Compounded interest in m times per year. M times per year. What does that mean? If you say yearly, you're saying that m is 1, once a year. That's how many times per year. If you say quarterly, how many quarters are there in a year? 4. If you say semi-annually, that means there's 2 of them. If you say monthly, how many months are there in the year? 12. What if you say daily? We assume there's 365 days, and I'm not sure if you know, or they're going to use weekly. How many weeks are there in a year? There are 52 weeks in a year. Now, there are other variables besides m, but m you have to find all the time. It's really right there. They go by a few things. P is the principal. That's like the deposit. That's how much you start with. Oops, I misspelled deposit. I'm so embarrassed. What's R? R is the interest rate. And that's always in decimal. How about A? What's this A? A is the amount after a given time, which means the balance after some time has passed. And we have this. What am I going to use? Let's use this on it. We have this T, and t happened to be in years. So that's here, t was in hours. That's allowed. But if you're coming up with this for investment, we go by year. So if I could plug things in, I'm in good shape. And let's make sure we know how to do that. We have a calculator. Now we have to practice how to input these things in it. And let's take the first problem. The first problem says, use the following information. Now this formula will be provided on the exam. You really don't need to memorize it. I provide that to you. A credit union client deposit $9,000. Deposit original amount. P is $900. Earning 9.5% interest, which means R is 0.095, always in decimal. Compounded quarterly, doesn't that mean that M quarterly? How many quarters are there in a year? There are 4 of them. Find the balance. Tell me what A is at the end of, and in this case, we want T to be 19 years. Well, it's a matter of plugging things in properly, right? And A equal P into 1 plus R over M raised to the MT. One, I need to write the formula correctly, and secondly, I have to use it right. I'm looking for the account balance. Principal is $900. The interest rate is 0.095 divided by M, and N happened to be 4, raised to the 4 times 19 years. How much money would be in that account? And if you're rounding money, you always round to the nearest penny, so 2 decimals. As it is, 900 parentheses 1 plus, oops, I'm getting excited here, 1 plus 0.095 divided by 4. You could use that if you really want to make it look exactly the same. You don't have to. 0.095 divided by 4, all raised to the 4 times 19. As you, oops, 16, that's 16 years. 19. We're going to get out of the $900, 19 years from now, we're going to get $53.75, 53.75.72 cents. Remember, I'm putting less than 1,000. I'm getting about 6 times as much in 19 years. If you're willing to wait 19 years, of course, that's the catch. That's how we do retirement. Of course, the formulas are a bit more involved, but the same idea. And how does this work? A painter wants to have $1,000 at retirement in 25 years. A painter wants the balance to be $100,000 in retirement. The time frame is 25 years. That's what they have. By making a one-time deposit, he wants to deposit, or she wants to deposit, a certain amount now and get $100,000 at the end of 25 years. How much money does the painter need to deposit, given that the account is compounded monthly? How many months are there in a year? 12. And the interest rate is 5.5% or 0.055. So this is something like, I start planning for my retirement, and I notice by the time I retire, I'm going to own my house $100,000. So you know what? How much should I put right now so that at retirement I'm debt free? Assuming you inherited some money or something like that. So the formula doesn't change. The formula is A equal P 1 plus R over M raised to the MT. Well, let's fill in the blanks. We want 100,000. P is how much I should deposit right now. 1 plus R is 0.055. M is 12 raised to the 12 times 25. Now, do you see that I want P by itself? Wouldn't you say all what you have to do is divide both sides by this mess? Wouldn't P equal 100,000 divided by 1 plus 0.055 divided by 12 raised to the 12 times 25? And the amount I should put in right now and get 100,000 25 years from now would be 100,000. I'm going to show you another way of doing this. 100,000 divided by parentheses 1 plus 0.055 divided by 12 raised to the 12 times 25. If I put in today $25,363.51. If I go 52, since I rounded down, I'm gonna get less than 100,000, maybe 99,900 and some dollars. If I want to be over, I round up, but that's what it is. Another way of doing this, a slightly different way of doing this, is for you to say, you know what? Let me figure out what this is. Let me figure out what this is. Plug this in my calculator. So I'll take 1 plus 0.055 divided by 12 raised to the 12 times 25 equal. I got it. And don't you divide 100,000 by that? 100,000 divided by my answer will give me the same result. You can always do that. If I put about $25,000 right now, 25 years from now, I'll get 100,000. That's true if you could find such interest rate. What is it? Chase used to give 5%. Now they don't anymore. Not Chase, JP Morgan, they don't exist anymore. How about this problem? Same deal. How much money must be deposited? How much money should I put in right now? Account bank that pays 4% interest, 4.75%. That is 0.0475. Compounded semi, that means M is twice a year. In order to get, we want a total of $7,000 after the given time period. We have a problem. The time period is given by 12 years plus 9 months. I need to convert months into years, so months at the bottom and year at the top. Each 1 year is 12 months. So that is divided by 3, that's 3/4, 0.75. So in 12.75 years, you have to convert the years. Same as the problem before, I'm going to have 7,000 is what I want. Principal is what I'm looking for. R over M raised to the MT. I suggest you write that as many times. This way you'll get to really memorize it, which is something you should do. You don't have to for this class, but you should have that memorized. M is 2 raised to the 2 times, and we said 12.75. And we could do the same as what we just did. I could say P equal 7,000 divided by this mess, and you have the option of doing what I just did. I'm going to take 7,000 divided by parentheses 1 plus 0.0475 over 2 raised to the 12 times 12.75. Not 12, 2. And I should put in today $3,847 and how many pennies? And 27 cents. All right, and there's our homework. All right.